That's not the right lecture, is it? Oh, I just need to change the title. Okay, so like ask me some questions then about dictionaries, so I can clear up that confusion before we start today's lecture. No, worst time ever. That should be here. Okay, so what's the difficulty with dictionaries? What's this class called? Introduction to Programming? All right, this is okay. So ask me questions about dictionaries then, so I can clear you guys up. Sorry, can you say that again? All of them. When you invert it, it has to, like, so when you invert something, the thing that goes to the thing that becomes the value has to become a list automatically, unless your original dictionary is one-to-one to begin with. We talked a little bit about this, right? That dictionaries aren't necessarily invertible. The one-to-one dictionaries are invertible, right? But the other ones you always have to, like, do you want to do an inverse dictionary now? I can program it, right? All right. We definitely talked about this, though. We did a bunch of inversions, actually. Oh, no, I don't want to close you. Cancel. Close. Okay. Okay, so let's just build a dictionary then. So the problem is you're saying that if I have a key that goes to here, 1 goes to 2, maybe 2 goes to 2, 3 goes to 2. And maybe 4 goes to 1, and 5 or 6 goes to 3. Okay, so we want to now invert this dictionary. So we're taking H, which is, I have to get typing. Right, so again, the problem is that, as you pointed out, if I invert this dictionary, what does the key to map to? Right? And what I'm saying is, you can't invert this dictionary then. Right? As soon as you can't invert the dictionary by just inverting the keys and the values. You can only do that if this would never introduce ambiguity. Right? This would never. Like, I have to use mathematics nomenclature here. Like, this dictionary is one to many, right? There are lots of things that, sorry, this is many to one, sorry. Right, this is many to one, right? Because I'm not doing a very good job explaining this, right? Maybe I have to draw a picture. Okay, so like a dictionary is like a mapping, right? Where we're mapping from some domain into some range. And here, what the numbers that I have on the left? 1, 2, 3, 4, 6. And on the right, I have what numbers? 1, 2, 3, right? So we have some picture that's like this. 1, 2, 3, 4, 3. So this is what I mean by one-to-one. 6 goes to 3, and everything coming to 3 is 6, right? So there's one thing that goes to one thing, both directions. This is many things to one thing, right? Because when we invert this, we try to find the inverse of this. Basically, that's just flipping the arrows. Right, so you have 1, 2, 3, 4, 5, 6, and then 1, 2, 3. So the inverse dictionary should take 1 to 6, should take 2 to 1, 2, 3, and should take 3 to, 1 should have gone to 4. 4 up, and 3 can go to 6. Right, so this is the problem here. Right, so you're sort of saying, which one do I pick then? The last one? And I'm saying, no, 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 make it a list. Right, so strictly speaking, the domain is going to be different. Right, because the range is going to be different. The range now has to be lists and not just scalars. Right, so let's invert this dictionary. Right, so if the dictionary coming in was, if this was integers to integers, it always has to flip to this. List of integers, integers to list of integers. Right, when you flip, the second thing has to become a list. So then we can do the inversion. So here's our inverse h. Let's just say that's nothing so far. So then we have to go through the keys of h. For the keys in h, I want to make so the new key is going to be h at key, right? That's the value, and the new value is going to be key, right? So this is what we want to do. We want to replace the key and value, and now I have to sort of say, if this new key already exists in my inverse, then just append this to my inverse, new value. Else, I have to, what is going on today? Else, I have to instantiate this. So h at new key gets set to the singleton list of the new value. And then let's return h inverse. Okay, let me just call this in. List is not defined. Right, well, no wonder. Type object is not subscriptable. Yeah. I'll get there eventually. There we go. So I have my h, and let's find the inversion of this unhashable type list. Where am I trying to hash a list? Here? Oh, sorry, this is the wrong dictionary. There we go. Dictionary object has no, new key. So there it is. There's the inversion. Right? It's not exactly the inversion that you would expect, because you don't get to just swap the domain and range. Okay? So the answer to your question is just make one of the things has to become a list if the dictionary isn't one-to-one to begin with. If the dictionary is one-to-one to begin with, then that's trivial. Then you just walk through and make all the keys. But that would require you to determine the dictionary is one-to-one in the first place. Let's do that. Let's determine if a dictionary is one-to-one. Definition is one-to-one. Right? Let's take h dictionary. I don't know what's in it, and let's just return a bool. So what do we do here? Right? Ensures that there is no value for which there is. Ensures that there is no values val1 and val2 for which there is a key such that h at key is equal to value of 1 and h of key is equal to value of 2. Did I do that right? One thing can't go to two things. No, there can't be two keys. I did this backwards. There can't be two keys such that there is a value such that h of key 1 is the value and h of key 2 is the value. Okay. This is the statement that asserts one-to-oneness, right? So now we just have to go and encode this somehow. So ensures there's no value. Okay, I think we can just do this by testing lists. So ensures that there is no keys for which there is a value. Oh, let's just do two loops. So for key in h, so what do I have to do here? So I need to look at all of the h of keys and ensure there is no two keys which go to the same value. Oh, so okay. I know how to do this. value count is a dictionary. So for key in H, if my value, which is this, is in the value count, then return false. Else, value count at this value is 1. So I'm just counting the values as I see them, right? And as soon as I count a value beyond 1, it's false. So let's have an example of a one-to-one dictionary. I'm just going to make the constant the identity dictionary. Okay, so this should return false on H and true on F. Let's load it in again. So is one-to-one on H, is one-to-one on F. Oh, I didn't return anything. Okay, well, since it made it to the end, I would assume that it would return true. Okay. Helps a little bit. Like, so you just have to remember that you can walk through the dictionary by using the keys. Like the keys are, the key is the only way to access values in the dictionary. Right? So you always have to like have a loop like this. So is there anything else I can clarify about dictionaries? A little bit, right? Because I really want you guys to like understand these, because your assignment is going to be very difficult if you don't really have a good hold on these. So maybe one more question and then we can move on. That's good? Nothing else? Okay. So maybe I can post this online for you guys. But yeah, go back and watch the lectures on dictionaries. So okay, in any case, let's do the thing that we're supposed to do today. So this is the last topic. I hope you realize we're approaching the end of term quite rapidly. December 5th is the last day of classes, inclusive. That's always a little bit confusing. So December 5th, there are classes on December 5th. Right? Although it is the last day of classes. Our last topic is going to be object-oriented programming. This is a little bit of... you guys aren't going to appreciate object-oriented programming until you write a piece of until you write a piece of code which is very large. Object-oriented programming basically is just a technique for staying organized. But I'm going to talk a little bit more acutely about this. So I've mentioned before the notion that there are programming paradigms. And you guys have only learned one of them so far. So the paradigms are broken into two groups: imperative programming and declarative programming. And in imperative programming, the type of programming that you guys are doing, the programmer says what to do. And you say what to do. You can give these instructions by grouping instructions into functions, which is called procedural programming, which is what we do. Or if in addition to grouping instructions, you also group memory. Right? So a function has a set of instructions as well as allocated memory that it can remember stuff persistently. Right? Because remember, when we have functions, as soon as the function terminates, it dumps everything. Like it can't remember something. Like your functions, unless they use a global variable, cannot remember the number of times it was called. Right? Because that memory is just erased every time the function disappears. If you give the function persistent memory, then it can become an object. Right? So if we group instructions along with memory, we get an object. And that's the second sort of type of imperative programming. And imperative, the word imperative, means to give an authoritative command. So it sort of makes sense here, right? That what we're doing is imperative programming, because we're just saying do this, do this, do this, and do this, right? We are responsible for telling the computer to produce something that we want. The second type of programming paradigm that you guys probably haven't seen unless you've written some type of database software like SQL or stuff like that. You don't declare what to do, you declare what you want. Right? So in a functional programming paradigm, you would tell the computer what you want through various function applications. Right? Maybe like you define calculus and then say you want an integral. In logic, you basically state a system of fact and rules. the database programming would fall into this category, right? You want to say, find me all things in your database such that the thing that you give me is a man who is failing computer science last year, right? That's a logical statement, right? You're not really writing an instruction to make something. You're asking a question of the computer. And the final way is that you can just explain math to the computer. You can say, the solution I want is the local minimum of this function that I'm going to hand you. Just go optimize it, right? So there's various manners in which we can communicate with the computer. And you guys have only made one branch, right? So there's still many branches that you guys are going to have to make. You guys are going to have to become experts at all the paradigms, right? You'll get to focus on one of them ultimately. But as good computer science students, you're going to have to at least know how to work in every one of them a little bit. You should be, by the end of your careers, you should be able to read code from all of the different paradigms. So what is object-oriented programming and how does it differ from the imperative program that we've been doing? Well, in truth, there is nothing that you can do in an object-oriented program that you can't do in a regular imperative program. Again, this is just a strategy to stay organized. And I hope you guys are beginning to understand that keeping your code organized is important, right? As the complexity and size of your programs grow, right? If you can make sure that if you want to make sure that you break your program into fundamental pieces, and then you make sure that those pieces work, and then you connect them to get like a larger program, right? Instead of breaking your stuff into tasks, if you are instead able to break your problem into objects and then define how these objects interact with one another, that will be a different way of designing a program. So an object, right, and how I sort of said it before is that all an object is a function plus persistent state memory. But we have some terminology that we're going to have to use when talking about objects. So an object is a collection of data called fields or attributes. So the fields and the attributes are the persistent state memory, along with code grouped into something that we call methods, right? So an object doesn't have a function, an object has a method, right? So we can take an object which has fields and methods and pass that to a function, right? So just make sure to keep this terminology separate, right? So objects have state memory called fields and attributes, along with instructions that it can carry out called methods. And then outside of objects, we have these things called functions, which take anything and return something. Here's the example of a first object. I want to do this in the terminal. So let me just copy this out. Or maybe I'll just type it all in. So it's class point. Touch objects. Has anyone done Java programming in high school or something? You guys are going to hate this. You're going to hate the self object, because I hated it. Okay, so here's our first object. I want to define an object which is almost useless. So another word for an object is a class, right? So Python uses the class word rather than object when you're creating it. Notice that I didn't say define class, I just said class. So I want to make a class that just creates a point. And maybe this point, so this is the first method of the class, which is a special method which initializes it. And maybe I can say self.x is 0 and self.y is 0. Okay. Now, I forgot to mention something very important. But what else is new? An object has a notion of self, right? An object can say, do something to me, right? Change one of my values or call one of my methods that can change one of my values. So at every object, you're going to have to pass this self tag to every method that you use. And all of the method attributes have to be keyed by this self.something terminology, which is kind of annoying. So how does this work? Well, so there's my class. Let's read it in. Objects. Okay, so I have this point object. So I can say, give me a point P, make it a point object. If you ask for P to be printed, it's not going to be very useful. It's just saying, well, P is a point object at this memory location. The cool thing is, and if we get time, you can actually, in the class, write a special function which tells the object how to print itself. So maybe next week I want to make a matrix object. I know you guys hate matrices, but it'd be nice if you can come up with a matrix object which could print itself nicely to the screen, right, in a square. And so let's try that next week. The type of P is just itself, right? Its type is of object point, right? So you've almost declared a new type here. How do we use this? Well, I can refer to P's X value like this, and I can refer to P's Y value like this, right? By just using these dots to index into its attributes. I can change the values out here, and I can, what else do I want to do? That's all I want to do for now. Okay, so I can now be out here and manipulate values. Note that I can have multiple people, or multiple points. Right, so here's another point, and as you see, its X and Y coordinates are 0, because they weren't affected by this change we did on P. So we really do have 2 points with the same type of structure. The next thing I want to show you is this initial command, or initialize method, is able to take in inputs. Right, so I could say, okay, so take in 2 inputs, X and Y, and set the point to these initial values. Right, so this time I can say, give me a point P, make it the point 2, 3, give me another point Q, and make it the point 3, 4. So in this case, we can see that I have created 2 different points. Right? And then the fun stuff comes later when we tell Python how to do stuff like this. It's not able to do it yet, but later on in your careers, you're going to be able to tell Python how to do arithmetic on your objects, which is great, right? Because now we can say, well, here's 2 points, and here's how you work on 2 points, or here's 2 matrices, and here's how you work on 2 matrices. You guys know what complex numbers are? Ish. This would be a great lab example, right? Just implement complex numbers using objects, right? Because you can add. They're basically vectors. They're basically vectors of length 2. But in any case, that's how you create a basic object. So let's do another one. What did I say here? First object. Okay, let's try to go through some of this motivation, but let's do it fast because I dumped some time talking about dictionaries. Okay, let me write a method here so I can show you how we call a method. So I can say def print point, right? Or maybe def, okay, we'll do 2. Definition print point takes self, and it does something, and maybe definition double point, right? Self. Okay, so if I want to print the point, I can just say print self.x, self.y. And if I want to double the point, I can say self.x times equal to self.y times equal to, and these return nothing. And alright, so now I can go into here, I can define a point, maybe 2, 3. I can say print this point. Now, be careful. These are methods, right? Functions. So this won't work, right? Because it's saying what the print point is a function. You can't call a function like this. You have to call a function like this, right? Oh, because I printed it wrong. There we go. 2, 3. So this is me using the method of the point. So watch this. So I can have Q. This is a different point, right? 3, 4. And I can print point, print point like this. I can also say double this point, Q double point, and what will happen when I print it? 6, 8. Right, so it's nice. You can like, say I have an object, it remembers all the stuff that it needs to do, and it also has access to methods that it uses. So, you guys have been working with objects this entire time, you just haven't realized it. Because I can have something like this, strings are objects, because I can do something like x is dot replace, I think I can replace p with p. Yeah. Right? So the reason that works, the reason you can say dot method, is because strings in Python are actually objects. I can also do something like this and say x is dot sort, right? And it will sort itself. And the reason it's able to do this is because a list is an object in Python. Like basically everything is an object in Python. That's why it's not a very efficient language, right? Because everything's wrapped in a bunch of unnecessary code. But you have been using objects this whole time. Now, I was supposed to ask you this motivating question to sort of guide you to want to use objects because out of basically desperation. So here's the question. Suppose we had to represent a group of students and store data about them. And the data I want to store maybe is their name, their GPA, and their user ID. How could we store this information in Python? Maybe if you guys give me one, I'll give you 2 more. Like if I gave you guys homework and I said something like, I'm going to give you a bunch of information about students, their ID, and their GPAs. And then I'm going to ask you a bunch of questions about those values. How would you store the information in Python?
You can have a field in the object for each category.
No. Without using objects. Objects will ultimately be the correct answer, right? Huh?
Dictionary
Of what?
of strings.
Well, be more specific, right? So what's the key, right?
The key is a string, and the value is whatever value. Like for example, if it's 8, it's going to be an integer. If it's grade level, it's going to be an integer. If it's name, it's going to be a string.
Well, I'm giving you a specific problem. I'm saying I need to remember student, grade average, ID. How do you store that in the computer? So you're saying I'm keying names with what?
So for example, if the key is a string, and the value is a number.
So you want this. Okay. That's not bad. That's better than one step back. So one step back from your better answer is just use lists, right? Just store a list of triples, right? And just remember that we're storing name, GPA, user ID. And you could do that. But there's like a lot of downsides to this, right? First of all, you have to memorize the attribute order somewhere. Like the list ordering is very relevant, right? You can't swapping the GPA and the user ID in the fields swaps those values in the attributes, right? So that's not very good, right? That you have to somehow remember the order of the attributes to pull out information. Second thing that's hard about this, how do you find a student in this? Right? You have to walk all the lists and look at the first element, right? That's not very efficient. When you're programming, none of these things are going to have meaningful names, right? You're just going to have data at 3, which is going to be a triplet of student information. That's not very useful to look at in the very least. There's no easy way to compare students, right? I couldn't find the student with the largest GPA quite easily. And this is fixed. I can't support multiple types of students. If I wanted to add another field to this, you couldn't. This is like fixed now. So we wouldn't want to use nested lists to do this. So your idea basically is one level up from that idea. Okay, so we can at least key the student name to this pairing, GPA and user ID, but we still have to remember the order of the attributes in the list, right? There's still no easy way to compare students, and we still can't support multiple types of students. Yeah?
What I was saying was more like for each student, they have a dictionary.
So like this. Okay, so you can make like a dictionary of dictionaries then. Right, so name 1 goes to a dictionary which takes GPA to GPA and ID to ID. This isn't a bad idea, but I think as you guys are finding out now, having a dictionary of dictionaries isn't like it's really hard to keep things organized. It's not very hard. It's not very easy to manipulate something like this, right? So I'm hoping you're appreciating now that like, if you had objects for your assignment, it would be way easier, right? But we're just asking you to do something messy on dictionaries on purpose. Okay, so also, how would you, if you wanted to add another attribute, it wouldn't be easy either. Or you'd have to walk through every dictionary and add it. So of the three options, maybe this is the best one. But really, the answer is, well, let's just use a object. Right? The natural thing to do here is to create a student object. That student object can have attributes, right? Name, GPA, ID. And then we can define methods in order to compare them, right? And do other things. So how much time do we got? Oh, okay, tons of times. Let's get rid of this. So let's define a student. What does the student need? Okay, so we have to define this initialize routine. All of our methods have to take self. That's what's the thing that's going to annoy the Java programmers. What do we need? What do we need here? We need a self dot, what did I say? GPA and self dot user ID, or maybe student ID. You guys get the drift. So this is a GPA. It's an integer. Oh no, it's not. It's a float. And user ID is an integer. So this gets GPA. This gets user ID, and we're going to name the object after the student, maybe, right? Do we want any methods? Maybe not. So let's just go into here. So I can do something like, okay, so create a Paul Verbeek object called student, right? What's the highest GPA you can have? 4? Well, I have a 5. That's how good I am. And my user ID is 0. I was the first. Can't assign to literal. Huh? What have I done?
You're assigning to a string.
I'm assigning to a string. Right. That's better. So I have a Paul Verbeek object, right? And I can say, what is the GPA of Paul Verbeek? It's 5.0. It's impossibly high. What is the user ID? Paul Verbeek, 0, right? So look, see now you have, this is very clear what you're asking for now, right? Even as like a statement in Python, saying paulverbeek.gpa is a lot more clear than saying dictionary at 3 at 1, right? You'd have to go back and like look at a dictionary of basically telling you, oh, well, 1 is the name, 3 is this, right? This is basically putting that pivot table in the middle of these things for you. And then you'd be able to do stuff like maybe print, but maybe, I wonder how complicated, because we can make now a class of class. So what's a synonym for class? Like a collection of students is a class. So I want to make class, right? And I want to make that class a list of students. Okay, anyways, let's just go with the slides. I have to come up with a synonym for class. There's the first object. There's that. There is, oh, okay, so we already did this. Yeah, Wicca, Slim Shady. So let's just skip this one. Okay, counter. This is not a bad one to talk about. So objects are really good when you're trying to like duplicate real world type of scenarios. So let's do one called counter. Class counter. Now suppose you have a bunch of runners, and these runners have like a race ID. Okay, so maybe we should start typing. So we have maybe runner ID. This gets set to 0 at the beginning, but we can pass that in as an integer. And self.lapse completed equals 0. Right, so imagine that you have a marathon race, you have a bunch of runners who are running in the race, and you need to keep track of how many times a runner has run around the track, right? So you're going to need a counter for each person running, right, basically. So this is how we're going to do it. So, well, we can at least
see that I can create a counter. So maybe runner. Well, let's be a little bit more sophisticated. Let's make runners a list. I can say runners gets appended this counter. Maybe this is the runner 1 and laps completed is 0. Yes. What's happening? Oh, right. I have to also do this. Runners is this. Runners.append. Yep. What's the problem?
Two problems. One, if you're passing two arguments when the init function only takes one.
Oh, correct.
You're also assigning 0 to runner ID every time, not the runner.
It's also correct. Thank you. Oh, God. It's not. Thank God it's Friday. Okay. So in runners of 1, there should be an object. Sorry, runners of 0, there's an object. And I can ask maybe how many laps completed. 0. Okay, so let's write a method. And the method is click, basically. Right? If this is a counter, we can click the counter. And what should this do? This should take self.lap completed and add 1 to it, maybe. All right, so let's see if that will work. All right, I shouldn't have put that into a list. So we'll just say a runner gets this counter, and maybe it's the runner ID is 1. And then I can look at the runner.lap completed, 0. And I can say runner.click, 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 runner.lap completed, 3, right? And I can have another runner, counter, it's the second runner, and my another runner, laps completed, 0. Or I can say another runner, click, 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 lap completed, right? So notice here I'm doing something which I could have said something like this, runner.lap completed plus equal 1, right? But that is not following the object design principle, right? Things that you do to objects should be methods, right? You shouldn't be affecting them outside. This is a recipe for disaster, right? So even if I wanted to reset this counter, I could reset the counter by doing something like this. The laps completed by the runner is 0. That would reset it. But the design principle would say that we should do something like this instead, that we should give a method to counter which can reset itself. And then we say something like this, runner equal counter 1. I misspelled completed, lap completed, what, is that still wrong? Completed. Great, okay. So now I can say a runner is a counter 1. I can say runner dot click, 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 runner dot, I should have wrote a print command, but whatever. Laps completed is 5. Now I could say runner dot reset the counter, and runners dot lap completed 0. Right? So you can even see in the code how even using the object is sort of like a real world analog. It's like someone's really there with a counter going click, 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 click. Oh, reset, click, 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 click. Right? So it's just a way to keep things organized in your mind and in the compiler. Yeah.
I'm just curious, can you make like the variables immutable?
Yeah, you want to make them inaccessible to the users outside. So 2 answers to this, yes and no. Okay. There's something called the private variable, and I think you denote private variables by naming them with an underscore to begin with, which is why I said never name something beginning with an underscore, because it's reserved for this use. Oh, well, that's why this init starts with these underscores around it, right? This is technically telling the programmer, hey, this is a private object. This is a private method to the object. Don't use me. right? I'm really only supposed to be used by the counter object. Now, it doesn't actually stop you from using it, right? It's expensive. It would be expensive to lock out the rest of the compiler from entering the memory of those objects. So in Python, we basically just have like a set of agreements. It's like, if I name something beginning with a double underscore, you're not supposed to touch this. You can if you want, well, but you're not supposed to, right? This is unlike other languages which would like actually prevent you from accessing it. So be careful. Python's very flexible, which means that we get to do a lot of cool things, but it also, you can screw up a lot of stuff, right? So anyways, these double underscores are technically for telling the user that this is not supposed to be touched outside of the object. There's the counter. Okay, so I'm going to leave this to you guys. So why don't you implement a method, class, which can add a student, but the student should itself be an object. And next time, we're just going to do tons of object examples. So if you guys have a fun example, just email me. You guys have a good weekend. Study.